Okay, so we're going back to using the trig identities again today. This chapter is a little bit shorter, so I have the lesson today and tomorrow, and then there'll be a quiz on today and tomorrow's lesson on Tuesday next week. So, we have these identities we talked about, reciprocal, quotient, Pythagorean. Those are not new, they're just here again so we have them easier to use. Then the even and odd identities we've talked about a little bit before, but I've never explicitly written them out. So these are when we were finding inverse angles. If the sign inside was negative for sine, then it can move outside, and the same for cosecant. And this also matched up to tangent. If the sign was negative on the inside, then it can move to the outside. Cosine, again, is special. If it's a negative angle on the inside, then it's the same thing as a positive angle. So I don't know if we'll use these today, but we'll use them in the future. So on numbers 1 and 2, it just wants me to simplify these expressions to try and make it to one term. So taking a look at number 1, what do you notice about both of these terms? What do they have in common? Which trig function? Fine. So what I'm going to do is I am going to factor out a sine x. So I'm going to write that out front in parentheses. What is sine x, cosine x, no, cosine squared x divided by sine x give me? Cosine squared. And then negative sine x divided by sine x? -1. So then I want to look up at the top of my page and see if there's any way I can either rewrite sine or cosine squared or 1 that would help me solve this problem. So if I look up at my identities up above, are any of these helpful? So I have sine squared plus cosine squared equals 1. So how would you like me to rewrite what I have in here? What? What am I replacing? Okay, so I'll replace the 1. So I have sine x, and then the cosine squared x was there to begin with. Now instead of the 1, I'm replacing it with sine squared plus cosine squared. And I'm putting that in parentheses, because it went in the spot where the 1 is, so I need the negative to distribute to both of those terms. Okay, so then I'm going to go ahead and distribute that negative. So I gave it to both the sine and the cosine squared. Okay, then what do you want me to do next? Okay, so when I combine my terms, what do I get? Okay, then what can I do to finish this off? Multiply it, so that's going to give me what? Negative sine cubed. questions on number 1? So you're trying, if it just says simplify, you're trying to get it down to 1 term if you can, or to like sines and cosines if you can't rewrite it anymore. So right here in parentheses, yeah, we used the Pythagorean. We replaced the 1 with the sine squared plus cosine squared. So if I take a look at number 2, do these ones have anything in common? Well, no, because I have sine, cotangent, and cosine. Those are 3 different trig functions. So the first thing I want to do here is I want to try rewriting in terms of sines and cosine. So I'm going to have sine of t. Cotangent, how can I rewrite that? I'm trying to rewrite it as sines and cosines. Okay. No, because there's a plus sign in between. So like these are 2 separate terms. So then what do I want to do with the term on the right? I can't cross them out because the cosines are technically both still on the top. Yeah, so I'm going to multiply them and then they're going to become squared. So, in general, if I'm trying to add a whole number and a fraction, what do I need to do to the whole number so I can add it to the fraction? Same denominator. So what do I need to multiply sine of t by to have the same denominator here? Sine of t over sine of t. And since it's the same thing as multiplying by 1, I'm okay. I'm allowed to do this. So when I multiply those together, what will I get on the numerator? Okay. So now that they have the same denominator, what can I do? Add them. So sine squared plus cosine squared is a Pythagorean identity, so I can rewrite this as 1 over sine of t. Is there a way I can rewrite this so I don't have a fraction? What is it? Cosecant. So questions here on number 2. Okay, so on the ones on the back, these ones are factoring. So if I think about it, this is kind of the same thing as if I had x squared minus 1. How would I factor that? So secant squared minus 1 is the same thing as like if I just had x squared minus 1. How would I normally factor x squared minus 1? No, that's solving, not factoring. Factoring is when you break it up into the 2 sets of parentheses. Because this is a difference of squares. So instead of doing x, I'm just going to write the secant. So I'm going to have secant theta plus 1, and then secant theta minus 1. And since this is factored, once I get to it broken up in parentheses, I'm all good. So this is my answer for number 5. Okay. The only thing I need to pay attention to when I'm factoring trig functions is that it's all the same trig function. So I can't have like sine and cosine appear in the same sentence. So number 6, This one's kind of like 4x squared plus x minus 3. So just thinking about 4x squared plus x minus 3, how would I solve that one? Do you remember? Yeah. So I'm going to use the AC method here. So AC is 4 times negative 3. Gives me negative 12. What multiplies to negative 12 and adds to my middle value of 1? Okay. So then I'm going to split up my middle term, and I'm going to actually use the word tangent instead of x. So instead of having tangent, I'm going to split it up to 4 tangent, and then minus 3 tangent, minus that 3. Okay, then I want to factor by grouping. So I'm going to split these into 2 groups. What can I take out of my first group? What do they have in common? 4 tan. Bless you. Bless you. So when I pull out the 4 tangent, what do I get left over? 4 tangent squared divided by 4 tangent, just tangent. 4 tangent divided by 4 tangent. Anything? Yeah. Then on my second group, what should I take out? Negative 3. What is negative 3 tangent divided by 3? Which theta? Oh yeah, plus 1. So negative 3 tangent divided by negative 3. Tangent. Negative 3 divided by negative 3. Plus 1. So notice the parts inside the parentheses are the same. So I can use the inverse of the distributive property to put my 2 outsides together. So I'm going to write those in a set of parentheses. And then the repeated part just gets written at the end. And it only gets written once. So this is my final answer. Questions here? Okay, so if I take a look at number 9, notice these are different trig functions, but it still wants me to factor. So I want to see if I can either turn all of these into cotangents or all of these into cosecants. So if I look back at my identities, is there a way I can turn cotangent into cosecant, or the other way around? Where? Yep, my third Pythagorean identity, I can replace cosecant squared with 1 plus cotangent squared. So that's what I'm going to do. Okay, so then I want to go ahead and combine like terms before I can factor. So this 1 is going to get added to that negative 3. Gives me negative 2. This is the same thing as if I had x squared minus x minus 2. So then how would I... So I'm going to have cotangent of x minus 2 And then, oops, that should have been cotangent. Cotangent of x plus 1. Questions here? When I have something like this, I need to figure out a way to rewrite those so I can continue factoring.